Hi everyone. In this video, we are going to talk about adding and subtracting rational expressions with different denominators and do several examples. First of all, let's talk about the method. In order to add or subtract any type of fraction, you need to have the same thing on the bottom of both fractions. In other words, you need to get common denominators before you add or subtract fractions. And to get common denominators, start by finding the LCD like we did in the previous video. Then multiply the top and the bottom of each fraction by what that fraction is missing from the LCD. And finally, once the denominators are the same, add or subtract on the top and keep the bottom the same. If you can factor after doing all of that stuff above, you should do that because sometimes you can factor and something will cancel as the last step. Now let's do our first couple examples. The directions say write the rational expressions as equivalent rational expressions with the given denominators. The first fraction has 3x on the bottom. The second fraction has 6x to the second on the bottom. How do you change a 3x into a 6x to the second? Well, how do you change a 3 into a 6? You multiply by 2. But you can't just multiply the bottom of the fraction by 2. You also have to multiply the top of the fraction by 2. And how do you turn x into x squared? Well, you multiply by x. So really, we are going to multiply the top and the bottom of the first fraction by 2x. Distribute in the numerator, and we get 2x squared plus 6x as the missing numerator in the second fraction. For the next example, notice that the denominators don't look alike at all. We have an x minus 6 in the first fraction and an x squared minus 7x plus 6 in the denominator of the second fraction. Well, first step is, you guessed it, factor the second denominator. To factor, you need to find two numbers that multiply to equal the number at the end, the constant, and those same two numbers will need to add to equal the number in the middle, which is -7. Those two numbers are -6 and -1. Since the trinomial starts with a 1, you can go straight to your parentheses when you factor. They're both going to start with an x, and the -6 and the -1 that you got from solving the number puzzle go in the blanks. Now notice that the first fraction has an x minus 6 on the bottom. The second fraction has an x minus 6 and an x minus 1 on the bottom. How do you turn an x minus 6 into an x minus 6 and an x minus 1? Well, you multiply by what it's missing, which is the x minus 1, and you multiply that on the top and the bottom. On the top of the first fraction, we now need to FOIL. X times x is x squared. X times -1 is minus 1x. -3 times x is -3x. -3 times -1 is +3, which we can then simplify to get x squared minus 4x plus 3 is the missing numerator of the second fraction. Now let's use these skills to actually add some fractions. The first step in adding fractions that don't have common denominators is to find the LCD, like we did in the previous video. For this problem, the LCD is pretty easy. It's going to be a 3x. Which one has more x's? The first fraction. Which one has more 3's? The second fraction. Multiply those together to get the LCD of 3x. So we want to have two fractions that when we add them both have a 3x in the denominator. For the first fraction, how do you turn an x into a 3x? Well, you multiply by 3 on the top and the bottom. 9 times 3 is 27. And for the second fraction, how do you turn a 3 into a 3x? Well, you multiply by x on the top and the bottom. 8x times x is 8x squared. Now that the denominators are the same, which is good, your answer is going to have the same denominator in the bottom. It's going to stay the same. And on top, we're going to add the numerators, 27 plus 8x squared. Those are not like terms, nothing factors, nothing cancels, we're done. Now, an example where we subtract fractions, because remember, when you add or subtract fractions, you have to have common denominators. If you multiply or divide fractions, you do not need common denominators. First thing we need to do is find the LCD of these two fractions. You could make a factor tree for the 8 and the 12 and figure out which fraction has more of each specific factor like we did in the previous video, but all you really have to do is find the smallest number that both 8 and 12 go into. Both 8 and 12 go into 24. So 24 is your LCD. 8 goes into 24 3 times, 12 goes into 24 2 times. Actually, 24 is only part of your LCD. We also will need an XM. For the first fraction, we have 8x and we want 24xm. What is it missing? Well, it's missing a factor of 3m, so multiply the top and the bottom of the first fraction by 3m, which will give you 3m squared. How do you turn 12m into 24xm? Well, you multiply by what it's missing, which is 2x. On top, 5 times 2x is 10x. The bottom, 12m times 2x is 24xm. Now that the denominators are the same, the denominator stays the same, and we subtract in the numerator. Nothing factors, nothing cancels, we are done. The next one's a little bit different. Notice that the first fraction has a 9 as a GCF in the denominator. So we want to start by factoring out the GCF. And now notice, both denominators have an x plus 1. What is the second fraction missing from the denominator that the first fraction does have? The second fraction is missing a 9. So multiply the top and the bottom of the second fraction by 9 to get common denominators. I'm going to kind of skip a step here, because now I can just write the common denominator, which is 9 times parentheses x plus 1. In general, leave the bottom factored. Distribute on top, but leave the bottom factored. And then distribute the 9, so we will have 10x plus 9x minus 9. Combine like terms to get 19x minus 9 in the numerator, and 9 parentheses x plus 1 in the denominator. Nothing factors, nothing cancels, we are done. In the next video, we're going to have some examples where we can factor and cancel as the last step. I think we have 2 more examples. For this one, notice we don't have a fraction for the second thing, but you can write that as 4 over 1 to turn it into a fraction. Then notice that your LCD is going to just be 4x minus 1. If you wanted to put a 1 in front, you can, but 1 times anything is itself, so you don't need to. The first fraction already has the LCD, so you don't have to do anything with the first fraction. What is the second fraction missing from the LCD? Well, it has the 1, but it's missing the 4x minus 1. So multiply the top and the bottom of the second fraction by 4x minus 1. And when you distribute the 4, we're going to have 16x minus 4 as the numerator of the second fraction. Now that the denominators are the same, we can combine like terms in the numerator and keep the bottom the same. Be really careful here. When you subtract a fraction, you need to subtract both terms in the numerator. So we really have a 5 from the first fraction minus 16x. And be really, really, really careful here because I see so many people make a mistake. This is not a minus 4, it is a plus 4 because we need to distribute the negative. And as the last step, combine like terms so that we have negative 16x plus 9 in the numerator and 4x minus 1 in your denominator. Nothing factors, nothing cancels, we're done. Oh, I guess I only had that one last example. In the next video, we're going to do a few more challenging problems of subtracting. Thanks for watching and have a good day. Take care.